Hello, my name is Joshua Tyler, and today I'm going to be continuing my series on going through MATLAB's Cody, which is a online tool that MATLAB has created for people to get into coding using MATLAB. So this allows you to solve problems in a sandbox that gives you fundamental knowledge from the ground up of how MATLAB processes data and how you can use MATLAB to process your own data. So I finished with problem 8, so today I'm going to start with problem 9, and let's see if I can find problem 9. Who has the most change? Okay, you have a matrix for which each row is a person, and the columns represent a number of quarters, nickels, dimes, and pennies for that person in that order. Okay, so we start from 25, 5, 10, and 1, 25, 10, 5, 1. Which row index of the person has the most money? Okay, so what I'm going to do is I'm going to solve this actually in the MATLAB IDE, so we can see how to use MATLAB. So here I've got the first problems that I solved saved with their solution. So I'm going to say problem. Actually, let me show. Okay, so if you want to create a new script, you can say new script. That'll open up a new script, and then you can save that as something like something like that. But the way I do it, I do new script problem 09, and let's see what that's called. Who has the most change? So when you name MATLAB files, the first part of the name, the first entry of the name, the first character needs to be a lowercase letter. And then after that, it doesn't really matter what you put in. You can put in an underscore. You can't use dashes. You can't use slashes because that's how you access directories. You can't use like @ or exclamation points because that's how Windows handles directories. So I'm going to say who has the most. You can't use spaces. Who has the most change? Okay, so I'm going to double click on that and that'll open it up. So here on MATLAB, we have our working directory here on the left. This is the basic setup that MATLAB gives you. It's the default. So here, so here on the left is our working directory. In the middle here on the top, we have our file that we are working on and editing and running. In the bottom, we have a command window that we can type in different commands into. So let's say I want to do problem 01. Let's start here, and I should get printed out the variables that are output from problem 1. I can also run command functions. So let's say x equals 2 plus 1. I should get the return of that function out. So, and then on the right, we have our workspace variable. So any variable that we create in our MATLAB scripts that hasn't been deleted yet, we'll see them in the workspace, and we can actually do something good. We can click over here and it'll actually show us the variable, if it's an array, if it's a table, if it's a cell array, if it's a categorical, and we'll see we can actually go in and look at the whole entire variable or whole entire component, which is really easy. Well, it really makes it simple. So here I'm going to say close all, clear all CLC, and this is just to make sure that, so close all closes any graphs or figures that I've opened up previously, clear all clears out the workspace, and then CLC clears a command window, which is useful for starting something from scratch. So let's say our prices, let's create an array of prices. So we started with quarters, which is 0.25, and then we had nickels, which is 0.05, and then we had dimes, which is 0.10, and then we had pennies, which is 0.01. We should see that show up there. Okay, so then let's say A is our input. So this is how many nickels, dimes, or whatever that we have. So let's see if A, the random integer. So okay, so in terms of the amount that we can have, there's no upper bound to the amount that we have. We're just bounded by 4. So what I'm going to say, so you can only have a whole penny. So there's a function called rand I, which means a random integer, and you can put the bounds on that integer. So let's say 0 to 20. So any of the entries in this random matrix can have a value between 0 and 20. And then I'm going to say comma after that bracketed 0 through 20, and I'm going to create another random integer within that rand I. I want to bound it 2 to 10. So I'm going to say we can have a random amount of rows between 2 and 10. And then in terms of columns, I'm going to say there are 4 columns because there's 4 different coins that we can have. So if I do that, so I'm going to... So just looking at one random outcome of A, we're going to see we have like 2 quarters, 20 nickels, 17 dimes, and 5 pennies for the first person. So it looks like that was set up correctly. So what I'm going to do then, I'm going to create a for loop with incrementer or iteration I, 1 to size of A. And if I say 1, I'm looking at the number of rows. And if I say 2, I'm looking at the number of columns. But here, I want to go row-wise. And I'm going to say total equals, and I'm going to say A of I. So I'm selecting the ith column and then I use the colon to say I'm using every single column in that ith row. And then I'm going to use a dot multiplication, which means every, so let's see, prices. Okay, so let's see here. Oh, why is that throwing me in the sheet? So let's go into the command window and let's pick out a of I. Let's say A of 1, and then let's say answered prices. Okay, so we have 2 quarters, which should give us 50 cents. We have 20 nickels, which should give us $1, and 17 dimes, which should give us $1.70, and then 5 pennies, which should give us 5 cents. So that works. Oh, I forgot the equal sign. I equals. Okay, so the total gives us that correctly. So I'm going to then say sum of A to I. Okay, so then at the end, so I'm going to say create I. So before that, I'll say total equals zeros, 1 to size A1. So I'm creating total as an empty array of zeros that takes on however many, that's essentially a vector with a length of however many rows are in A. So then I should see here total. So this should be my totals for everybody in A. So A has 7 rows and our total has 7 entries. Now that we have that, so we'll say B, let's see, what is the index? So B equals, so index equals 1 to size A1. And then I'll say B equals index of total equals the max of total. Okay, so that's what they want. So I'm going to, so now I'm going to say display A equals display A, and then I'm going to say display totals equal none to string total. And then I'm going to say B row num2 string B holds the most value. Okay, so we have totals equals $3.73, $2.93.70, and $5.08. So we're going to say row, let's see, index equals 1 to 4, and then total equals max of total. Yep. So that holds true. And then we see here row 1, 2, 3, 3 holds 3, or yeah. Row 5 holds the most value. Run it again. See row 1 holds the greatest value. Then here, yep, row 5 does hold the most value. So now we can copy this code over. So I'm going to copy prices into here. Say total. So here, I'm just going to say a index equals 1 to size A. And let's see if that'll run it. I'm going to say X, well, I'm going to say this. I'm going to pull in that. I'm going to pull in this function that I wrote for it. So then we actually see it as an array. That looks about right. Okay, so now let's submit it and see what it says. Easy peasy lemon squeezy. Great. All right, well, let's go to problem 10. New script. And determine whether a vector is increasing. Let's try that. So the issue I had there was the file name was too long, and MATLAB does not like long file names. So I had to kind of cut down on that file name. Also, when I run something, I've gotten used to pressing F5 on the keyboard. That's the command on MATLAB to run the file. So if you see it run without me actually clicking run at the top, that's because I pressed F5 on the keyboard. That's just what I've gotten used to. That's muscle memory. Okay, so return the true elements if the input vector is increasing monotonically. Okay, that's a weird word. Okay, if each element is larger than the previous. Okay, so this should be easy. So let's say x equals 1, 1, 2, 3. So I'm going to say for I equals 1, 2, let's say I equals 2 to length x. If x of I is greater than x of I minus 1, let's say greater than or less than will break. Then we'll end it. Then if I equals length x, y equals 1, else y equals 0. Other way around. Okay, so what I'm saying here is I'm going to start at the second entry, and then I'm going to go to all the way to the length of the vector x. Then I'm going to say if x is less than or equal to x minus 1, which means it's, it has not increased for that vector. I'm going to break that for loop, and then I'll say, well, if it didn't break the for loop, then I should also equal the length of x because I'm iterating it to the length of x. So if I ended up becoming the length of x, then that means that this condition was satisfied for every entry in x. Otherwise, if the for loop was broken before I was able to achieve the length of x, then I'm going to say no. This condition was broken somewhere in the vector x, therefore it does not increase the entire time. So let's solve that problem, and let's see what variables they want. So I'm just going to say for I equals 1 through length x, 2 to length x, and then they want what as an output? Then we're going to say, let's see, so here instead of 0 or 1, I'm going to say true, and here I'm going to say false. This should be yes. So I'm going to check this with random integer, let's say negative 10 to 10 of possible values. I'm going to give it one row, and I'm going to give it random integer of, let's say, it can be 3 to 5 entries long. Okay. That over from my code, and we'll submit that. Oh, they want a different variable, true, false. Now, let's submit that. That should go. Assertion failed. So let's see why that did not work. So it returned true. So I got to the last iteration. Okay, here we go. Okay, so let's do something different. Let's say, okay, so what we're going to do is take the difference. So we're going to say x diff equals x of 2 to length x minus x of 1 to length x minus 1. And that's the same thing as taking the difference. So if we look at x1, so the difference between 1 and 0 is 1, 2 minus 1 is 1, 3 minus 2 is 1, and then negative 4 minus 7. So then I'm going to say if, let's see, what's the command for any? I'm going to say if sum of x diff less than or equal to 0, y equals false, else y equals true. So we'll simplify that code there. So then we'll say true false equals false, else true false, 0. With that should be a better way to solve that. Well, if I can spell it right. Go with the medium there. Okay, so now let's do problem 11. Back and forth rows. So gonna go here, create a new problem 11, back and forth rows. Copy this over. Okay, so given a number n, create an n by n matrix with the integers 1 to n squared, one back and forth across the row. So n equals 3. So 1, 2, 3, 4, 5, 6. Let's see, one back and forth across the rows. Okay. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. Okay, so what we're going to do is we're going to say n equals random integer from 2 to, well, let's just say n equals 3. So we're going to have a 3 by 3. So let's see. Okay, so then what we're going to do is a counter equals 1. So then, let's see, what do they want as the output? A equals zeros, 1, n by n. And then we're going to do is for I equals 1, 2. A. Let's just say A equals 1 to n squared. You get 1 to 9, and then we should get, let's say index equals 1 through 9. So then for I equals 1 to n, A of I equals index of A through I equals index of I minus 1 times 3 plus 1 to I times 3. That should create that array. So then A should be 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's how you get something to essentially break down from rows into columns. Well, from a single long vector into rows with column length 3. So then that column length 3 here, and that can be anything. So let's just say n here. Okay, so then we'll say A of 2 through 2 to n equals flip A of 2 through 2 through n. Then let's look at that. 1, 2, 3, 4, 5, 6. Okay, so then let's say if I is divisible by 2, so if let's see, -1 times I, or -1 to the power of I is greater than 0, A of I equals flip. Else why is that not hitting? -1 squared should be 1. -1 to the 1 is -1, and then -1 squared. So why is that not? Ah, yes. For some reason, it doesn't like doing that. So what it's doing is it's taking 1 to the power of I and then making it negative. So we've got to force it to look at -1, to force it to square -1 instead of squaring 1 and then making it negative. So now we should be able to see 1, 2, 3, 4, 5, 6, 7, 8, 9. So now let's see. Let's make n 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, blah, blah, blah. Yep, looks like that works. So let's go ahead and solve it. I'm about 30 minutes in. Unrecognized function in. Ah, yes, because n needs to be declared in the scratch pad. Yep, 1, 2, 3, 4, 5, 6, 7, 8, 9. Easy peasy. Now let's go for problem 12, and then I think I'll finish for today. 12. Give you a find command. It's ridiculous. Why is problem 12 not up? Okay. I wish there was I wish there's a way to see the problems in order on here. So let's see if we can find problem 12 here. Fibonacci sequence. That should be simple enough. 12 Fibonacci sequence. Okay, so what we're doing, given the nth Fibonacci number, output f is 5. 1. Okay, so this is actually pretty interesting. So we have n, say n equals 5. So we have, let's say f1 equals, well, let's create an array called f, and we're going to say equals the first two numbers of the Fibonacci sequence technically are 0 and 1. So then we're going to say for I equals n 1 through n. We're going to say f of 3. We're going to create a new vector. F of 3 equals f of 1 plus f of 2. Then we're going to say f of 1 equals f of 2. And then f of 2 equals f of 3. So let's see that. So we'll display f, and then we'll just say that that's 0 because that will fill in. So then let's see. So here we got 0, 1, 0, 1, 1, 1, 1, 1, 2, 3, and then 5. Okay, so then if we look at, we should see this third column. This third column here should be the Fibonacci sequence where 1, 0 plus 1, 2, 3, 5. Yep, makes sense to me. And then our output b equals f of length, or f of 3. So then let's say n equals 10. 5, 0, 13, 21, 34, 55. Okay. And then let's try n equals 7. Then b should be what? B equals 8. In minus 1. You get 5. One less iteration. Fine by me. Okay, so essentially what we're doing is we're adding the first two entries of the vector here to the third one, and then we're just shifting it back. So we're saying entry one becomes entry two, and then entry two becomes entry three, then entry three becomes the sum of the first two, and so on and so forth. So then we're going to say then f equals f of going on the scratch pad, and this way we don't run into memory issues. We only keep a memory of 3 vectors. The issue is just that we have iterative issues. Okay, so then let's try just one. Try one that shouldn't mess things up too much. Okay, so let's submit that. All right, and I think that's where I want to end for today. I'm already at 37 minutes, which is a long time for a YouTube video. So thank you for joining me. I hope you learned something, and I'll see you again if I do.